An inequality has lots of solutions. The solution is a set of real numbers x that make the inequality true. To solve a linear inequality, you solve it just like an equation, but when you multiply or divide an inequality by a negative number, you reverse the inequality sign. You can also represent inequalities on a number line. A full circle filled in represents greater than or equal to, or less than or equal to. If the circle is not filled in, it simply represents greater than or less than. We solve this inequality just like an equation, so the first thing that we need to do is expand the brackets, which gives us 12z plus 48 is less than or equal to 20z minus 40. We then get two different solutions depending on which side we take our z over to. So, way 1, if we subtract 20z from each side, we get the following. We can then take away 48 from each side to get minus 8z is less than or equal to minus 88. We then need to divide by minus 8. Because we're dividing by a negative, we reverse the inequality sign and we get z is greater or equal to positive 11. If instead we subtracted 12z from each side of the equation, we would get 48 is less than or equal to 8z minus 40. And if we add 40 to both sides, that gives us 88 is less than or equal to 8z. And finally, we just need to divide by 8 to give us again that z is greater than or equal to 11. Now we have two linear inequalities, so we'll solve each one separately and then draw them on a number line. Firstly, we have 2x minus 10 is greater than minus 6. So 2x is greater than 4 and x is greater than 2. Our second inequality is slightly harder. So 15 minus 2x is greater or equal to 8x plus 35. If we add 2x to both sides, we get 15 is greater or equal to 10x plus 35, which gives us 10x is less than or equal to minus 20, and x is less than or equal to minus 2. Now we can draw a number line. Our first solution is x is greater than 2, so we draw a circle at 2. It's only greater than, so we do not fill in our circle, and it's all the values of x that are bigger than 2, so we draw an arrow towards the positive x direction. Our second solution is x is less than or equal to 2. Again, we draw a circle, but this time we fill it in. And this time x is less than minus 2, so all the values below minus 2. And again, we draw our arrow this time to the negative x direction. Set notation can also be used to represent inequalities. You will have probably come across this before at GCSE. For example, if we were representing x is less than or equal to a, or x is greater than b, we can represent this in different ways. Firstly, as shown, this tells us x is an element of the set of values that are less than or equal to a, or greater than b. Secondly, we can write it like this. So x is an element of the union of two sets. So x is either in one set or the other. Here we have the set where x is less than a, together with the set where x is greater than b. The third way, which we can use, in this case a is -4 and b is 11, is the union of two intervals. Square brackets indicate the end values being included in the interval. However, round brackets indicate the end value is not in the interval. To use set notation, we must first solve each of the linear inequalities. So again, we'll do each of these separately. If we take the first inequality, we need to expand the brackets. This gives us 4x plus 8 is less than 24. So 4x is less than 16 and x is less than 4. If we then take the second inequality, 2 minus 3x is less than or equal to -16, and we subtract 2 from both sides of the inequality, we get -3x is less than or equal to -18. And then we're dividing by a negative, so we need to reverse the inequality, giving us x is greater or equal to +6. Our solutions tell us that x is less than 4 or x is greater or equal to 6. And so we can write x as an element of the union of two sets as follows. X is an element of the set of values for x where x is less than 4, unioned with the set of values for x where x is greater or equal to 6. Now complete textbook exercise 3D, page 47, the easy question 1, medium question 2 and harder question 3. Do all of these questions and see one of the maths teachers if you need help.